This problem and all other practice problems for Calc 2 here at Rutgers can be found in Sarai's studies. A link is in the description box below. Does the following series converge or diverge? Here we're going to be using DCT, the direct comparison test. So we always want to establish the test that we're using on paper, and then we want to write down the rule. Again, if you don't know how to recall the rule without memorizing it, watch the video linked in the description box below. But the rule is as follows: if the sequence A of n is less than or equal to B of n, and the series B of n converges, then that must mean that the series of A of n will also have to converge. And then just take the opposite signs, and then bring everything else down. Alright, so DCT is 5 simple steps. I remember it is IBB, CC. I stands for information, so the information that we know plus the information that we need. What we know is that our sequence A of n is always the given sequence, and then what we need is to find our B of n. So that brings us to our second step, which is B, which stands for B of n, find B of n. So how do we do that? We take our given sequence A of n, and we ask ourselves, at large n, this becomes what? Basically, as n gets really big, what becomes insignificant here? I would say that this one becomes insignificant, and this 3 becomes insignificant, and the only thing that's really significant are these n's right here. So guess what this is? This is our B of n. Which brings us to our next step, which is B, but this time B stands for behavior. We're trying to find what the behavior of the series is, whether it converges or not. So we have the series from n is equal to 1. I see n is equal to 1, so I write that here. To infinity of B of n. And I want to know if this converges or not. Now, in this step, you will only ever use the p-test or the geometric test, so you have to find a way to write it in those forms. So always simplify, basically. So this can be rewritten as n to the 1/2. These cancel out, so we just have n here to the first power. And so 1/2 minus 1. 1 minus 2, that's negative 1/2, so that just means that we have 1 over n to the 1/2 as our simplified series here. And so now I see that this is in the form of 1 over n to the p, where p is equal to 1/2. So therefore, I'm going to be using the p-test. The rule for the p-test, the way that I remember it, is PG-13, like the movie rating. So p is greater than 1, forget about the 3, and then converges, and then the opposite is true for diverging. Remember that p is equal to 1/2. That's obviously less than 1 because it's 1 being divided, so it's obviously going to be smaller than 1. So if p is less than 1, then we know that this series is diverging. So here's our little sentence here. So this here is our condition that's met. So now if this is met, then we hope that when we compare A of n to B of n, we hope that this is true, that A of n is greater than or equal to B of n. Because if this is true and this is true, then we can say that this is true, and we'll have an answer to whether this series, our given series, diverges or converges. So that brings us to our next step, which is the C, which stands for comparison. So we're comparing our A of n and our B of n. So I'm going to take my A of n and I'm going to take my B of n. I'm going to put a little circle in the middle. So this one is an interesting one because both the numerators and the denominators are different, and you can't really tell which one's bigger. So when you get to the point where you realize it's not as easy to compare these two sequences, this is the point where you have to decide to do another test, and this is the segue to the limit comparison test. So if DCT doesn't work, try LCT. So we're going to do this exact same problem with the limit comparison test and see if we can get the same answer, but in an easier way. I'll see you in the next video.